Hey, welcome to the sixth session of AWS Certified Cloud Practitioner. Um, my name is Untitled. Um, I do have AWS experience and GCP experience. I was recently certified to be a Certified Cloud Practitioner. Um, we did cover the cloud concepts, the security and compliance. Now we're going through the technology aspects of it, which covers like 33% of the portion. In later sessions, we'll also cover the billing and pricing. So let's focus on what we were doing. As usual, if you could hit the like button and subscribe to our channel, that'll help you get more relevant content. If you're interested in AWS, getting certified, there's a lot of content we're uploading every week, so you should be able to get access to that. So last week we looked at all the storage services. This session we're going to look at compute services. So the first few that are boxed here are the most important, and that's where most of the questions come in from. The rest of them, it's important to know because some questions could be there and you will have to eliminate the choice or choose one of them. So if you understand theoretically what it does, that will be enough to answer those questions. But let's dig deep into the first few boxes and then touch upon the next one. That will be sufficient for you to pass your exam. So the first one is an EC2 instance. Most of you would already be aware of what an EC2 instance is. But essentially, if you currently have a server on-prem, so your company has a on-premises server, so EC2 instance is somewhat of a equivalent of that, but it's not actually a full server, but it's a virtual machine or a virtual server. So EC2 instance is actually a full form of Elastic Compute Cloud. So you can provision an EC2 server, and then you have access to that server to install all the software on it. You can put in any kind of requirements, use those files, attach EBS volumes or EFS volumes, or mount EFS volumes, and then use that information. But essentially, you get a compute power on the cloud, and you can use that anytime. You can use it to use it to run batch workloads. You can use it to have a web server which actually hosts APIs, or you can actually host websites, or you can just use it for any kind of workload that you do. So if you want to run a database, then you can use that server to install any database that you want, including like Oracle, MySQL, and then use it as a database server. So you can just use that virtual machine in any way you want, and that virtual machine in the Amazon AWS world is called EC2 Instance. And what it does is it provides scalable computing capacity. What that means is the computing capacity can be scaled up or down. You can add more instances and then scale it up, or you can go ahead and like change the available resources, like the available hard drives or RAM in the EC2 instance itself, and then redeploy your application and then relaunch it. Or you can just create a copy of that EC2 instance and create multiple instances, and our workload can be done using the first instance or the second instance, or you can scale it. There's something called an autoscaler which we'll learn in the next couple of slides. But so we have scalable computing capacity. That's the most important part of EC2. With an on-prem, you buy a server, you're going to use that server. Sometimes there'll be some capacity that most times you'll have a lot more capacity than you need, because in case additional traffic comes in, or there's a time where there's a lot of traffic, but other times where it's free, so that capacity gets unused. In EC2, you can actually uh, set it up such that you can scale up and scale down. So whenever you're not using it, you can probably give up the capacity, and to an extent, you can give up the capacity. And whenever you're using it and you need more, you can like provision more capacity. When you set up a EC2 instance, just like when you go and buy a server, you can custom configure your CPU. There are various types of CPU that you can install depending on whether you want a high compute workload, that is, it has a lot of like computing operations that it does, then you get a high compute. Or if it needs a high memory, like if it stores a lot of information in memory and then processes it, then you can get a high RAM, high memory CPU. You can get different types of storage. It can be SSD, it can be hard drives, it can be different sizes, different types of memory, different sizes of memory, and different networking resources. So I think we touched upon this earlier. Whenever we build an EC2 instance, we cannot just go ahead and provision that. That needs to be within our virtual private cloud or VPC network, and that needs to be configured. So you need to configure the network settings of that, and that whole VPC will be a walled off area where your company or your team can access the resources. Anybody from outside, if they need to have ingress or egress access, they need to be defined. Like all those ingress and egress has to be defined by us and set by us, so that any resource that gets in, like if somebody if you hit a URL and that launches, that goes to your website, and that is hosted by your EC2 instance. So we need to open up the ports that are going to use the website. If it's going to be a global audience, we'll have to open up to all the ports. If there are going to be just your company using it, then you have to open up only to your company's IP addresses, and then you have to custom configure the networking resources. So a lot of custom configuration required, but this is very similar to what you would do when you set up your own on-premises network, an on-premises server, and on-premises storage. So to keep it simple, the last paragraph here is talking about, it's like a remote computer running Windows or Linux. So you can choose when you set up the EC2 instance, you can choose whether you want a Windows instance or a Linux instance, and you can install whatever software you want on that, like including a web server that can run PHP code and a database server. This is typically like a LAMP server that you run for websites. So if you have a WordPress website and you host it on somebody's server, you can do that on an EC2 instance. You can set up EC2 instance, install the web server software that you want, install like Apache is the web server that typically websites use for WordPress. You can set up Apache web server, and then you can set up, you can install PHP, you can install MySQL database, and then you can install WordPress, and then set up all your WordPress blogs on this EC2 instance. Sometimes it gets confused with Amazon S3. So like for beginners, S3 is a storage service. You don't really need to go ahead and provision a computer for it or a virtual machine for it. You directly go ahead and store it, and it's used to store large binary files, images, videos, text files, logs, just that. And to the right, you can see that Amazon EC2 instance, what we do with it is we can launch it. First, we provision the resource. That is, we set up how much configuration we need for CPU, storage, memory, networking. That means you provision it. After you provision it, you can launch it. It means it actually starts up the server. You can connect to it so that either somebody writes code on it or looks up the log. So you can connect to it from either your system or from another service that has to connect to this EC2 service. Say there's another server that needs to connect to this server to run certain APIs, so that connection can be set up, and then you can start using it. So you have to launch, after you provision it, you can launch it, connect to it, and then you can start using it. There'll be a lot of questions about EC2, so I'm going to go a little bit more in detail. Like within the AWS Cloud, we build a VPC private only network. So that's a virtual private cloud. Within VPCs, there are some things called subnets. This is something we'll cover when we talk about networking. But essentially, we can have multiple subnets within VPC which have different networking rules. Say we can talk about this subnet can have access to the external world, but the other subnet can be completely private. So we can set up rules such as that. In this example, when somebody hits localhost 9090, um, it goes through the private public internet. So if somebody is using their local system to access AWS resource through the public internet, then that goes through a session manager tunnel, and then that gets into the VPC interface endpoint, and through that VPC interface, it, it, it if it has access to for the subnet to be allowing ingress, that is access to come from outside world to the EC2 instance, that's called ingress. So that is allowed. If that is allowed in the subnet, then we're able to access that EC2 instance. So you can set up the EC2 instance using the simple web interface, and then you can choose your choices and then set it up. Or when you really get into the world of setting up a lot of resources, you use the CLI or infrastructure as code, IAC, to set up your EC2 instances. Having EC2 instances reduces the time required to obtain and boot new servers. You can quickly scale up, scale down as your requirements change. With EC2 instances, you can only pay for what you use. Say, for example, you have a server, you set up your software, and then the software is not used by anyone, so you want to shut the project down. You don't have to pay for the server that you already bought for. You can just shut down the EC2 instance, delete the instance, and then you stop paying for it. The EC2 also provides developers and system administrators to build failure-resistant applications, and you can isolate yourself from common failure scenarios. So typically, a server goes down because of network, so you have a way to build the same EC2 instance copy in another availability zone. That's a common failure scenario. So in EC2, you can actually build a failure resilient application so it doesn't fail, or when it's prone to failure, you have an alternate path for the application to still run. So that can be built using EC2. So the biggest advantages are, just to reiterate, you can scale up, scale down. You can pay only for what you use. It provides ability to build failure resistant applications or fault tolerance. So there are types of EC2 instances with respect to like like we earlier saw how we can have different types of compute workloads, memory efficient workloads. Apart from that, there are also different types of way you can commit towards how much of the EC2 instance you use. That is, do you want to use this for the next 3 years and you know you're going to use it? Then you can set it up in a different payment plan. Or if you want to just use it as you go, which is the most commonly done, and it's the least commitment. Or you can choose something called spot or reserved, where you get better savings. Or if you want these servers to be always available to you and nobody else should be able to use these virtual machines, so you can go for a dedicated option or a dedicated server, and you can you can uh, you can completely have separate hardware for it, separate server for it, and then you can get assurance from AWS that nobody else would use those dedicated servers uh, other than you. So let's go through these. Typically, there are a lot of questions asked about uh, how you save with EC2 instances. Um, I think it also gets confused with the savings plan, which is the new and the most flexible pricing model. And they keep asking these questions about which is the right type of instance you will pay for. Will you use reserved instance for these, and will you use spot instance for these? Will you use dedicated instance for these, or savings plans? So the most common one, which is the typical one that people use, is on demand. The left top here, it has the least commitment. You just pay for what you use for. You 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 set up a EC2 instance, and then you just keep running your workloads on it. You don't really like give a commitment to AWS that you're going to use this for the next year or next 3 years to get some discount on it. So you just use it plain vanilla without any kind of commitments. The next one to the right is spot instances. Spot instances are where you get the biggest savings. These are um, any non-critical background jobs. So very important to understand that these are for non-critical background jobs. So in these exams, they ask a lot of questions where which instance would you use, and they use the word critical in one of the sentences, but they use batch or something else. But when they use the word critical, you cannot use a spot instance because if this is critical, uh, spot instances work in the way that it uses just the spare capacity that AWS has. So if AWS customers are running a lot of instances, those are running right now. Say there is remaining spare computing capacity, those can be built as virtual machines and built as instances for different people. So those people who have requested spot instances, those that spare capacity gets used. But the problem with the spare capacity is that these can run at any time during the day or can be interrupted anytime during the day. Say you want your workload to run between like 1 p.m. and 7 p.m. During the day, because people start using this at night after 7 p.m. and would not be using it after 1 p.m. So you want to run that between those times, and your workload runs only for an hour. So you have a flexibility of it running between 1 p.m. to 2 p.m. or 2 p.m. to 3 p.m. or 3 p.m. to 4 p.m. or any time, as long as it's finished before 7 p.m. So that's you're flexible with your start and end times. So that in that scenario you can choose this. Also, you should have a non-critical job. That is, if this job doesn't run for a day or doesn't run on a timely basis, would you have a problem with your business requirements? Or when you just run it the next day, would it just catch up, and would you be able to still run in your business as is? In that case, you can choose your spot instance. So two things with spot instance: you should have flexible start times and end times. You can schedule your job to run at 1 p.m., but you cannot be sure that it always runs at 1 p.m. It might get delayed because you're not having a spare capacity in AWS, or your job might be running, but AWS can stop it, can interrupt it, and then will 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 get your capacity back when they have spare capacity again. So they could stop your job which is executing in between, and then allow it to run again when they have spare capacity. So if your job satisfies all these requirements, then you can run non-critical background jobs. I'll give you an example of what this can do. There was a HR reporting software that ran a daily batch job to pull data from a HR system onto a HR data warehouse. The reporting of this happens every month for the HR system, and typically the users of the warehouse, they look for data which is uh, typically a month old. So the daily job, if it does not run for a day, it still can catch up and get the data from previous days. So if it doesn't run for a day and runs the next day, then that batch will process all the records since the last time it ran. So you could still catch up with all the data. So it can handle like delayed runs. It could handle interruptions in the sense that if the job is running in between and it gets cancelled, then when the jobs get restarted, it will understand where it was stopped and where it has to restart, and then it will restart from there and then run from there and then complete the process. So it was able to handle interruptions, and it was non-critical in the sense that it was not used by the main business of the company. It was more for internal users. Those were pulling HR reports. So this does not stop the business of the company. So for those kind of instances, you can use spot instances. Reserved instances are kind of your best bet when you know that you're going to use this application and run this application for a long time. So you typically can commit to an EC2 instance. So you choose your EC2 instance. You can say, I want a high compute workload. I need this type of RAM. I need this type of hard disk. And then you commit to that EC2 instance, including what type of Linux you want. And then you commit to that for a 1 or 3 year term. And if you like choose that, you get up to 75% off of your typical EC2 payments. The most expensive one, and very rarely some companies might use this. I've never come across a company which used dedicated servers, but this could be because of regulatory requirements that you don't want anybody else to use your server, or because you believe there could be a security vulnerability and you're having very highly critical sensitive data that you want to like have stored only on your server, and it cannot be moved from this server to another server. So you want to have it because of some legal requirement or because of highly sensitive data requirement. Then you buy a dedicated server from Amazon EC2, or you rent the server from EC2. This can be very very similar to what you have on-prem. For some people who have highly regulated in highly regulated industries, if they want to move on to AWS, they choose the dedicated servers for that those kind of applications which are highly regulated and have a lot of requirement with respect to data privacy and sensitive data. So that's the most expensive option. So there are 4 options that you use. The most at the bottom we have the savings plan. So the savings plan, and typically a lot of questions confuse you with the savings plan and the reserved instances. So this is where if you understand the difference between these two, you can easily answer those kind of questions. So savings plan are the newest offering from AWS. It's really more flexible than the reserved instances, in the sense that in the reserved instance you need to commit to what type of EC2 instance you want, do you want a Linux instance or a Windows instance? If you want Linux, what type of Linux you want? Is it going to be a Ubuntu or a Red Hat? So you have to choose all that, choose the type of RAM, choose the type of compute power you want, and then you commit to it. So when you cannot actually change it, you can actually resell it in a reserved instance, but you cannot really change that. So you commit to that whole EC2 instance using it for a year or 3, and you pay upfront. But in the savings plan, you don't have to actually commit to what type of EC2 instance you use. You can use this on both EC2 and Fargate. And Fargate is something we'll cover in the next few slides. It's another computing option that AWS, computing service that AWS has. But what you do is you commit to a dollar amount per hour or a dollar amount for the whole year that you'll pay, not to a type of EC2 instance that you use. So you say that I'm going to use $20 an hour of computing power for the next 3 years. So can you give me a discount? So they give you a 75% discount on that, and based on that, you get a commitment. AWS gets commitment from you that you're going to use their computing power for 3 years, and you get a significant discount off your EC2 prices. So that's the major note you need to make about savings plans. So again, just to remind yourself, there's a lot of confusing questions about savings plans and reserve plans. So the lock-in, if it's by dollar amount, then it's a savings plan. If the lock-in is based on committed usage of EC2, then it's a reserved instance. So in the savings plan, you can actually change the instance type. So if they talk about changing the instance type, then they're talking about savings plan. Okay, that is another slide about EC2 instances. Another important thing we need to understand about EC2 instances are the types of EC2 instances. They're not going to go very deep into this, but you need to understand what are the types and why those are being offered. The general purpose are the ones that have typical balance between the memory and the storage and compute power. So those are for general purposes. So typically most companies I've worked with have always used this, except one of the companies who needed data science workloads who actually used a compute optimized EC2 instance. But typically most companies go for a general purpose one. This has a balance of the compute power, storage, and the memory. So they don't like over provision any one of those. So you get a general purpose machine. So the next ones are compute optimized. So you could choose like C3, C4, C5. So those are compute optimized. That means you have a lot more computing power than the general purpose. Storage and IO optimized, like I3, I2, D2. Those are more optimized for storing the data, the hard drives, the SSDs, and for IO, so input-output operations. So those types are the next type. So those are typically used, like compute optimized are used for companies who need for applications that need a lot of computing. They process a lot of statements, so there's a lot of processing that's happening. Then you use a compute optimized. For a storage optimized, say you store a lot of data in this SSD, and you do a lot of input output. That means you get a lot of updates and changes. That would mean there's a lot of input output. For those cases, you use the storage optimized. The memory optimized is where there's a lot of in-memory information that is being processed. So for this, there are X1, R4, R3 type of memory optimized EC2 instances that AWS provides. And memory optimized are used for applications who have a lot of information in memory. That is, they want that information to be retrieved or calculated from in memory, so that it's much faster than using it storing it in a database and then retrieving it and then doing it. So it has a lot more RAM, than the general purpose machines or the compute or the storage IO optimized. The last one is the GPU or FGPA enabled. These are for like including data science applications, but a lot more for cryptocurrency, for any type of gaming infrastructure. So the GPUs are like gaming programming units, similar to CPUs, but they are much more optimized for processing like videos or processing animations. Um, it, they are used a lot for mining cryptocurrency. So if you want to set up a EC2 instance to mine cryptocurrency, you would rather use a F1, P2, or G2. Those are GPU enabled or FGPA enabled. And any type of blockchain related application that you build where the blockchain needs to be stored, the blockchain needs to be validated, you use this type of EC2 instance. So most of these is going to be questions about, do you understand what types of instances are there and what kind of applications they need to fulfill. If you understand that, you can answer these questions. You don't have to go much more in depth than this. Okay, that covers our EC2 instance. Let's look at auto scaling. So auto scaling is where like when you have an EC2 instance and say it's running at 30% capacity, that means that one instance is enough to like supply all the load. But if you look at the image to the right, whenever a user hits Amazon AWS through a URL or through a website or an IP address, then they'll have to like if they need to get like the Amazon Route 53 resolves that URL into an IP address, and then it hits, depending on the IP address, it hits our elastic load balancing machine. So the elastic load balancer, what it does is it helps with the auto scaling. So whenever you build the EC2 instance and then you attach that to auto scaling group, what that will do is it will create the elastic load balancer. You could set up some rules saying that whenever the capacity goes above say 70% or 80% of capacity, build a replica EC2 instance, and then it will auto scale that. So if you look at that image to the right, the elastic load balancer sends information to two availability zones that are active right now. The ones that are grayed out are not active right now. And in case the elastic load balancer gets the first request, and we set it up as a round robin, that is one of the settings in the elastic load balancer. What it would do is the first request would go to the availability zone 1, which is on the left, AZ1A, and the second request would go to the availability zone B, the third one will go back to A, and the fourth one will go to B, fifth one will go to A, sixth one will go to B, and so on. So that way the elastic load balancer balances the load between the two EC2 instances, and both these EC2 instances are in two availability zones, just so that in case one availability zone goes down, the elastic load balancer will understand that there's a problem with one of the availability zones and it will route everything to the other availability zone. Also, whenever the elastic load balancer knows that the EC2 instance is hitting more than 70% of its capacity, then it will auto scale the EC2 instance. That is, the grayed out EC2 instance would be brought up to life. So it will launch that EC2 instance, and then any new traffic will get routed to the new EC2 instance. So until the 70% of this load becomes to a normal, like say 50% or 60%, until that it will keep routing the new requests into the new one. and then it will keep. And then now that there are three EC2 instances live, it will load balance between the three. So it will provide the first request to the first one, the second request to the second one, third request to the third one, fourth request will go back to the first one, fifth will go back to the second one, and then the sixth will go to the third one. So it will go back to doing a round robin between these three. So lots to understand, but essentially auto scaling, what it does is we're able to scale up the instances and scale down um, when we build an auto scaling group. And we can also, to the left, we can see that we can build a minimum size, that is, it has to have at least 1 or 10 EC2 instances. We can say the desired capacity is like 2 or 20, and we can also say this is the maximum size it needs to, and then the auto scaling group will scale as needed. That covers the EC2 instances. Let's talk about light sail. So light sail is intended for simplifying the EC2 instance launch. So now you want to set up a WordPress server. So you'll have to do a lot of things. So if you look to the right, you'll have to build a VPC, and within which you'll have to build a EC2 instance, and within the instance you'll have to install the Apache web server. You have to install PHP, you have to install WordPress, and you'll have to install MySQL, and you have to build a connection between these two. And the VPC needs to have the settings so that people from outside can reach out to this EC2 instance. So a lot of settings need to be done when you actually do this using a EC2 instance. But with the Lightsail instance, you can go in there. The image to the left shows that you can choose Linux, Unix blueprints or Windows blueprints, and within that you can just choose OS only, or in this case they've choose apps plus OS. So you can choose what kind of applications you need on top of the OS. For example, here they've chose WordPress. That means it'll put in the Apache, the PHP, the WordPress, the MySQL. It'll set up the VPC. It'll do everything for you. It'll create a static IP address. It'll take care of storage. It'll also take care of data transfer and domain name service management. So all that is included by using Lightsail, which is pretty simple to start with. So this is typically enough for you to understand how to answer all the questions that come with respect to Amazon Lightsail on the exam. Probably only one more thing to add is, say you run out of your capacity or you're done with doing all this, and then you're running your website. Now you want to actually change the RAM inside it, or you want to change the version of PHP that it's running. You want to go to the next version of PHP, but Lightsail gives you like certain version of PHP. You want to change the version of WordPress. Currently, Lightsail gives you 4.9.6 according to this image. Say you want to go to the next version, but Lightsail has not provided it, or you want to do some small modification with respect to settings. You can actually migrate your Amazon Lightsail into a EC2 instance. So this is another aspect you need to understand for the exam. So if you want to migrate your Lightsail instance into EC2, you can do that from the Lightsail like the Amazon management console itself. So you can go there and change it. So that covers Lightsail. Let's go on to Elastic Beanstalk. So Elastic Beanstalk is kind of Lightsail with much more information. So Lightsail was a much newer service, and Elastic Beanstalk has been there for a little bit longer. Lightsail is a lighter version of Elastic Beanstalk. So what essentially Beanstalk does is similar to Lightsail. You can like, instead of launching your EC2 instances, setting up your VPC network, setting up your auto scaling, setting up your ingress egress, setting up your elastic load balancer. Instead of doing all that can be done using like the choices that you choose on the elastic beanstalk. So it makes it easy to manage that whole provisioning, load balancing, auto scaling, and application health monitoring. So you can do all that using elastic beanstalk. You don't have to do these multiple steps with respect to EC2 instances. Obviously, the problem that some companies face with respect to EC2 instances, like why would they rather choose a EC2 instance instead of taking Elastic Beanstalk or a Lightsail, is that they might need certain other options that are not easily provided on Elastic Beanstalk, or in so they might want to configure something else. They might want their VPC network to only talk to certain IP addresses, while Elastic Beanstalk does it for one or something like that. They want to change certain settings that may not be available in Elastic Beanstalk or in Lightsail, then you would have to choose your EC2 instance. That much is enough to understand for for this exam perspective. So essentially, under the hood, when you actually put in a like implement a Elastic Beanstalk service, it actually takes care of everything under it. It uses CloudFormation to provision the resources. That is, it does the EC2 instance, it does auto scaling group, load balancers. It also sometimes uses S3 so that you can have a copy of your application, and optionally RDS database that you can connect to as well. So you can do all that using Elastic Beanstalk. And the VPC sets up such that it accepts connections on port 80. That's the default setup. If you need more flexibility, then you go with Elastic Beanstalk. If you want to run a very simple application in the cloud, Lightsail may be the way you go. And if you want much more flexibility with respect to configuration, how you set up the network, how you set up the auto scaling, if you want to control all that, then you go with EC2 instances. That covers a lot of with respect to EC2 instances and Lightsail and Elastic Beanstalk. Let's go on to AWS Lambda. AWS Lambda is where you write your if you look to the right, if you want to just build an API or a web service, so you don't want to worry about setting up a server, setting up the OS on top of it, setting up the network for it. You don't want to worry about any of that. Then you directly go ahead and write your code in one of these languages: Node.js, C#, Java, Python, PowerShell, Go, or Ruby. And then you can still connect to like services such as S3, DynamoDB, SNS, Kinesis, etc. But if all your code can be done using these languages, you can do that in AWS Lambda. You don't have to actually provision a computer for it, a virtual machine for it, or set up any server for it. You can do all that using AWS Lambda. You can also have like expose that using an Amazon API gateway that you see that in purple, and then the end user can hit that API and then inquire the Lambda service and then get back the information. For instance, recently for one of the retail clients, we built like my company built a service that does a machine learning algorithm, and then it predicts like how much time somebody has to wait, and then returns it back to the API. So the retail customer's client would hit through our Amazon API gateway and hit our Lambda service, and our Lambda service would internally look to our DynamoDB tables and predict what wait time it would be, and retrieve that information back and send that information back to the API. And this was written in Python, and so we had an Amazon SAM model that was deployed, and that was deployed in Lambda as a Lambda function. So this can be done. So that's one way. And to the left, if you see the event triggers, you can also have your event be triggered like based on a trigger. For example, somebody uploads something on a S3 bucket, and then this gets triggered as a Lambda function. The typical example that I see on the AWS website is that for this, say for example, you have a website where people can upload their profile photo, and you want your profile photo to be a certain dimension. It has to be square, it has to be like this many pixels by this many pixels, but the person uploading the photo could do it in like multiple sizes. So when they upload it, it goes onto your S3 bucket. That could trigger a Lambda function, and the Lambda function could cut the photo into the right pixel size and place it back in the S3 bucket. So that can be an event trigger. So whenever somebody uploads it on to S3 bucket, there'll be a trigger that calls a Lambda function, and the Lambda function executes. So that can be doing it. So and for this exam, this is more than a technical exam, so they're going to ask you a lot of questions about how you pay for it, what do you do when you don't, when your code is not running. So understand those pieces. So as far as now you understand AWS Lambda, the next piece to understand is, in this piece you pay only for the compute time you consume. So if your Lambda function is not invoked, there's no charge for it. So the whole day today nobody called your API, you're not going to pay for it. Because you haven't really provisioned a computer or a virtual machine for it. It's not running there, so you don't have to pay for any of the power. Number one. Number two is, other than pay, there is zero administration here. So you don't have to set up any type of like servers, OSs, networks. So it's pretty easy to use, and it's zero administration. And this is a serverless tool. So this is serverless computing, and that, like, if you attended or heard anything from the reInvent that happened last week, the AWS reInvent that happens every year happened last week in Las Vegas. So some people from my company went there. So the most important thing they're talking about there is everything is going serverless. Every they're focusing a lot more on serverless, and Google Cloud has done this a lot already, and AWS is focusing a lot more on serverless computing. So even the Redshift database that AWS has is now serverless. So this AWS Lambda is another serverless tool, but this is for serverless computing. So that's another thing you need to understand. What about scalability and availability, high availability? So Lambda takes care of all that. So you just upload your code. It can be scaled automatically. So if there are multiple requests coming up at the same time, AWS will take care of provisioning more computing resources so that your APIs don't face a like delayed response or don't get timed out. Lambda also takes care of high availability. So if one of the regions is down, one of the availability zones is down, regions are down very rarely. It happened this week in AWS. AWS East 1 was down, but a whole region going down is very, very rare. But there are a lot of times where an availability zone can be down, or a part of an availability zone can be down. So when that happens, AWS Lambda will automatically take care of like provisioning resources in other availability zone, and your API will still be able to fetch the results. There may be a few failed requests because of the time that the requests failed, but automatically any new requests that come in will be routed to the new availability zone, and then people will be able to run their requests as needed. In the example that I told earlier that we set up for our company, we set up the trigger to happen from anybody pushing any code changes to GitHub. It automatically triggers the code to build a new version of the code in the AWS Lambda. So similar to that, you can set up triggers from GitHub as well, or any other Git tool. Okay, that gets us to Fargate and AppRunner. Let's talk about those. Fargate is a technology you can use with ECS to run containers. So when you set up a ECS, ECS is Elastic Container Service. So if you know what containers are, so containers are a package of like applications that go together, that get packaged together and get deployed together. The advantage of packages, like a virtual machine, it has everything that it needs to run that particular application together, and those get run on its own. So if you've heard of Docker, you already are aware of this. Otherwise, Docker containers are kind of an abstraction layer over a virtual machine. So the virtual machine, what it does is, you have your own OS, you have your own RAM, and some storage linked to it. It acts as though it's a real server in itself. Similar to that, a Docker container is something where you have everything provisioned for it. So a Docker container, you can assign some like a set of uh, uh, like applications together, package them. So if you need Python 3.7, and then you need these Python packages on top of it, like you need matplotlib, you need the mathlib. You want those to be pip installed, so all those can be requirements, and you could set all that up into a container, and then you put your application code on top of it, and that can be Dockerized into a Docker container. And to run this Docker container, if you want to do this manually, then you'll have to do a lot of EC2 instances, set up a cluster of EC2 instances. So you pool these EC2 instances together, and then you like manage the Docker container, and then Docker container can scale up and scale down as needed. So it can run one instance of it, or it can like run multiple containers, copies of those containers, um, based on how much load is needed. So for that, you could like if you don't have Fargate, you could actually set up a cluster of EC2 instances. But with Fargate technology, you can use those Elastic Container Services, which holds all the Docker containers. The Elastic Container Service is nothing but a place where you hold all your Docker containers, and then you could run the containers without having to actually manage the servers, the clusters of EC2 instances. You don't have to do any of that. AWS Fargate does that part of the servicing for you. You don't have to provision it, scale it, to run those containers. So you don't have to choose the server types. You don't have to choose when to scale. You don't have to optimize the cluster packing. So you don't have to do any of that. That is AWS Fargate. AWS App Runner, again, typically people use this with containers, but you could also use it directly with your code. What is the principal use case of this is for web applications and APIs. So if you have a web application and API, you might have heard of DigitalOcean, Heroku, or Google Cloud Run. These have been providers who have provided a service where you can directly implement your web service without really worrying about, okay, where do I what kind of server do I need, what kind of RAM do I need, what kind of like, do I need to scale this up, do I need to auto scale this, do I need different availability zones. You don't have to think about all that. These platforms were already providing it. So AWS has AppRunner from 2019, and they've been providing this service, which is similar to what DigitalOcean or Heroku or Google Cloud Run does. What it does is, behind the scenes, it actually builds a EC2 ECS cluster, and it uses Fargate to execute your containers. And then that way your web app can run without for you going to choose what kind of EC2 instance you need, what kind of how many EC2 instances you need, when do you need to what EC2 instances are part of the cluster, and how many clusters you have, like how do they interact with each other, what is the networking between those clusters, what kind of load balancer you have, how do they load balance between these applications. None of those things you need to worry about. Everything is taken care by app runner. So if you look at the information to the right, the picture there talks about how your code from GitHub can be used to build a service, or you could use the ECR, which is the repository that has all your containers. So Elastic Container Repository, the ECR or the GitHub, you could pull your code or your container from there. Based on that, App Runner in the background takes care of building a service, building a load balancer, uh, like setting up Fargate or ECS clusters so that those web services can be deployed there and used. So you just write the code and either merge it with GitHub or build a container and have those containers in uploaded to Amazon ECR. And then if you start your API's app runner, it will pull the code from GitHub or from ECR and then have your website service deployed so people can hit your API immediately. So understanding what this is, it's a serverless service. So you don't have to really provision your servers. Understanding that piece and understanding how App Runner can be run in two modes. One is in build mode, that is, it can pull from GitHub and builds the application. Every time you change it, you run a git commit. AWS can pull code from GitHub and build the application, or you can build it in container mode where you build a Docker container and that Docker compatible image that goes into a ECR registry. From there, your application can be built. So there are two modes. If you understand that, and if you understand that App Runner is something that can host web applications and APIs, and it can be done without provisioning your servers, that much is enough for the exam. Let's go on to the next few things. We'll quickly run through these. The batch, AWS batch, is, as the example says, it's for running batch workloads. The biggest difference is if you want to set up a EC2 instance and then run your batch, then you'll have to make sure you have the right type of EC2 instance, and then like set that up, provision that, launch it, connect to it, and then run your workloads. So any batch workload that you do, whether it's going to be a Java batch, a Python batch, or if it's going to be like we use Airflow, so Airflow batches. So any kind of batches that you run, so you can have those run on AWS batch. So the AWS batch is a service that automatically identifies what type of resources it needs, whether it needs more compute resources, more memory resources. It will provision the right type of EC2 instance it needs, and then like it will help you run those batch jobs. So for you just have to connect to the service and specify what type of batch jobs are needed, what is the code for that, and then submit those jobs, and then AWS batch will provision the right type of resources for that. The next one is AWS Outposts. This is needed for hybrid computing, and essentially Outpost is a software that you install on your on-prem local servers. So on your on-prem servers, AWS provides a software that either a AWS person or a AWS third party, like a company that I'm working with, can come in and install the AWS Outposts, and then those Outpost servers, what it does is you can use the same APIs that you use at AWS. You can use the same CLIs. You can use the same kind of hardware, same functionality. So it helps your hybrid experience come much closer with AWS. It is it's ideal for customers who want low latency or local data processing. So they don't want their data processing to happen on the cloud, because they want their data to process with low latency on their locations. So they don't want to go through the internet, go to AWS and then process the data and then come back. So they want their data to be processed in-house. But when they install Outposts on them, they can manage their servers, their infrastructure, similar to how they manage their AWS resources. So they can have similar APIs, similar CLIs, similar infrastructure tool commands, and then do that. Again, if you understand these keywords like hybrid computing, using the same APIs, and having a truly consistent hybrid experience, those are what you would trigger you to choose Outposts or not choose Outposts. So typically it will be like, what tool would you use for this? And there'll be 4 choices. You can either eliminate based on what you read, and if you don't see the words hybrid computing, you can eliminate the AWS Outpost option, or if you see hybrid computing, that might be probably the answer. So you'll have to read more to understand. The next one is AWS Serverless Application Repository. So this is a repository just like GitHub, or it stores a lot of application samples. Say for instance, you want to build a logging mechanism which builds logging, or you want to do some event and data processing. What you can do is you can go into the repository. There are a lot of publicly available applications. You can go and choose the application. You'll be able to, if it's a publicly available, you'll be able to see the source code, and then you can install it on your AWS. So people have published their code publicly here, just like people would do on GitHub. But these are serverless applications itself. So these are not. So you would use a SAM model template. The SAM model template says, defines what AWS resources you use. Do you use a S3 bucket? Do you use a DynamoDB? What type of DynamoDB do you have? What type of connection parameters you use? If it's S3 bucket, what bucket you use? What IAM roles to actually use so that you will get access to that. So those are specified in your SAM template. So essentially, there are 2 types of apps. One is a public, so things that people have publicly listed. You can go there, choose it, and then install it. Or your team can publish something within your team. So within the serverless application repository, your team or your company can publish applications, and those are available to be installed only within your company. So those can 2 types of apps that people can write into the repository. What you can do with it is you can pick those applications, quickly deploy it, and then you can start using it. Okay, the next 2 are the last pieces we'll cover for computing. Number 1 is AWS Wavelength. So AWS Wavelength is for edge computing and on the 5G network. So those are the keywords you need to remember, and if you see those, you typically have your answer there. Like what are the use cases? If you look at those images, if you're doing real-time gaming and on your gaming device you want to do some computing, so if the gaming device is connected to the 5G internet and you want to do the computing on AWS and then bring that information back to the gaming console, or if it's a connected vehicle, it's driving, it's connected to the 5G network, and it needs to send some diagnostic information to the AWS, and then it needs to get back some information quickly. Like typically, if somebody needs to connect to AWS, uh, they connect through the broadband internet. Um, for people, for IoT devices, for any kind of streaming application, like those that use 5G to actually connect to the internet, we built something called wavelength. Using AWS wavelength, we built something called wavelength zones. And the wavelength zones, any computing capacity that you keep within your wavelength zones, uh, like is can directly connect to the 5G network. It can cut down the latency hoops, and the traffic would be much faster, uh, and they'll get a huge speed boost. So for AWS wavelength, all you have to understand is it's based on the 5G network, like any kind of edge computing. Edge computing is where um, the computing happens at your location, at your device, at your facility um, quickly. So for those kind of cases, we can build something called wavelength zones. And if you have your EC2 instances set up within the wavelength zones, when your gaming console connects through 5G to the wavelength zones, and it gets the information back, it can be done pretty quickly. The last thing we'll cover is the VMware Cloud on AWS. VMware is a software a lot of people would have been aware of. Most of your companies might have used VMware on your on-premises. So you might connect through VMware to a virtual machine. Sometimes even to log into work, you might have to VPN through VMware and get to your office network, or you might typically for a developer machine, or for a like UAT machine, or for a prod machine, if you want to connect to that, you might use VMware to connect to those. So VMware has a lot of technologies that they use, and those are really popular on the market. So any virtual machine, they are the leading provider of that. So what VMware did is they partnered with AWS, and they're offering all their cloud technologies, on the AWS cloud. So VMware on AWS cloud is VMware's version of this. They have a alliance with AWS, and they're providing all their services, including vSphere, vSAN, vCenter, all those things they're providing on the AWS cloud. The biggest advantage that AWS brings to the table is that they have their EC2 instances are pretty up to date. They have very good workload capability. So it brings the advantages of VMware and AWS cloud together. And this can be used for compute, databases, Internet of Things, all those things. So any kind of IoT devices, databases, analytics, application services. If you're using VMware, you can shift over to VMware Cloud on AWS, which gives the added advantage of being on the AWS cloud. So that covers all our compute services. So if you have any questions, please let me know in the comments. Don't forget to subscribe. We'll get a lot more AWS Certified Cloud Practitioner training related materials. Always, thank you so much for watching. Bye.